All right, guys, we're going to take a look at the derivatives of inverse trig functions today. And much like the derivatives of regular trig functions, they're just going to be something that we memorize. But I think it will be a good exercise for us to look at the derivation of a few of them, maybe look at the derivation of inverse sine and inverse cosine. And then I'll give you the rest of them. The solutions or the derivation of all of them will be on Canvas. So if you want to look at how I derive all of them, you may do so. But let's just start with inverse sine and inverse cosine, and you'll probably get the picture of how the rest of them work. So what we start here with is inverse sine of x, and let's remember that inverse is a swapping of x and y. So y equals inverse sine of x would be the same thing as sine of y equaling x. We just haven't solved for y, but sine of y equal x would be the same thing as y equals inverse sine of x. We've just taken sine and we swapped x and y. Now, if you think about it, sine of y, remember it's sine of some angle. So this y value here is an angle, okay? And the x value here is a ratio. So the sine of my angle y is equal to the ratio of x. So if we think about trigonometry and all this stuff, that means if I were to draw a right triangle, okay? If I were to draw a right triangle, and I think of that angle down here as y, I know that sine of y, or opposite over hypotenuse, has to equal x, which means that if I think of the opposite side as x and my hypotenuse is 1, sine of y in this right triangle would return a ratio of x over 1, or just x. Okay, and if that is true, using Pythag to find the length of the third side would just be the square root of 1 minus x squared. Again, you just use Pythagorean theorem, right? A squared plus b squared equals c squared to find the length of that third side. The third side being the leg, you could think of that as a. And if that's the case, thinking about my inverse sine ratio as a right triangle, I would get a ratio, or a triangle with sides of 1x and the square root of 1 minus x squared. Okay? So again, we want to find the derivatives of these inverse functions. So I don't know the derivative of inverse sine yet, but I do know how to take the derivative of a sine function. So let's use this equivalent expression above, sine of y equals x, and take its derivative. So we'd have to perform some implicit differentiation here. The derivative of sine, as we know, is cosine. So my derivative would be cosine of y times the derivative of the inside, so the derivative of y, which would be just dy over dx. And then we have to take the derivative of the right side of the derivative of this x, which we know to be 1. So if I want to find what is the derivative, or I want to isolate dy over dx, I would divide both sides by cosine of y, and I get 1 over cosine of y. And you might be tempted to leave it like that, but we can actually simplify this using our right triangle. If we look at our right triangle, what's cosine of y? Cosine of y is the adjacent side over the hypotenuse. So if I think of, look in my right triangle, what's cosine of y? Cosine of y is just root 1 minus x squared over 1, or just root 1 minus x squared. So I could think of it as dy over dx equals 1 over the square root of 1 minus x squared. This right here, guys, dy over dx equals 1 over root 1 minus x squared is our derivative of inverse sine of x. So if I were to ask you what is the derivative of inverse sine of x, it would be 1 over the square root of 1 minus x squared. And again, this all came from first of rethinking the inverse sine function as sine of y equaling x. Y being an angle allowed me to create this right triangle. And then using that right triangle, I was able to derive the derivative. So the derivative of inverse sine of x, is just to repeat, is 1 over the square root of 1 minus x squared. That's something that's good to know where it comes from, but you'll just need to have that memorized. All right, so inverse cosine of x. Now, if you're one of those people who like a challenge and you want to see if you can derive this on your own, why don't you hit pause and then see if you can derive it. I'm going to derive it here in a second, but if you want to give yourself a challenge, it follows a similar pattern to what was above. All right, so if you tried it, you can follow along, see if you got what I got. If you didn't, you just want to follow me, that's okay too. So inverse cosine of x, let's rethink of that like we did above, as cosine of y being equal to x. And if you think of that, cosine of y being equal to x, let's think of y as an angle. And if I draw my right triangle and I think of y as my angle, make this in blue again. This time cosine of y is equal to x. That means my adjacent side, okay, should be, I'll make it in green, should be x, and my hypotenuse should be 1. That would return a cosine ratio of x, cosine of y equaling x. And again, if I use Pythag, that means my missing side, or my third side, would be the square root of 1 minus x squared, again, just using Pythag. Make it a right angle. So there's my right triangle with sides of 1x and square root of 1 minus x squared. So now let's take the derivative of cosine of y equaling x. That would give me negative sine of y. It's a horrible y equaling x. Okay. Oops, sorry. I totally screwed that up. Sorry. Negative sine of y times dy over dx. I'm thinking one step ahead and not focusing on what I'm doing. Equaling, what's the derivative of x? Equaling 1. So if we isolate dy over dx, we get dy over dx equaling 1 over negative sine of y. Well, from our triangle, we can determine what sine of y is. Sine of y is, again, the square root of 1 minus x squared. So I get dy over dx equaling 1 over negative square root of 1 minus x squared. That is my derivative of inverse cosine. If you got that, great. If you didn't, that's okay too. Hopefully you found the error in your ways and were able to correct it. So what's the difference between the derivative of inverse sine and the derivative of inverse cosine? Well, it's just this one negative, right? It's just this little negative here in the front. So it's just one of those things you have to be careful with, okay? So those are two of our six derivatives. We could do the same exact methodology and find the derivative of inverse tangent, but in the interest of time, in your interest levels, let's just go out and state what the derivatives are of each. And if you want to take the time to derive those derivatives, again, the solution key will be on Canvas, and you can find that yourself. So the derivative of inverse tangent is just going to be 1 over 1 plus x squared. Okay, so that's our derivative of inverse tangent. For inverse cotangent, my derivative is going to be y over dx is going to equal 1 over negative, and then in parentheses 1 plus x squared. So again, if you're comparing it to tangent, notice it's the same thing, but a negative on the outside. Okay. Inverse secant, derivative of inverse secant, is going to be dy over dx equaling 1 over x times the square root of x squared minus 1. So similar to inverse sine, but a little bit different. Inverse sine, if you remember, was 1 minus x squared under the root. This one is x squared minus 1. So again, they're similar enough that you can memorize them, but different enough where you can easily make a mistake. Okay? And then inverse cosecants, the last derivative that we'll need to find, dy over dx equals 1 over negative x square root of x squared minus 1. Okay, so those are our 6 derivatives of our inverse trig functions. You're going to need to have those memorized just like you've memorized the 6 derivatives of the 6 regular trig functions. Okay, the most common ones will be sine and cosine, but you'll need to know the other 4 as well. Okay, we practiced the derivation, we saw where the derivation came from, but in reality, all you need to do is have them memorized. Okay, so let's maybe run through a couple to see how it works, and then we will go from there. So perfect practice makes perfect. So we have y equals arc sine, which you'll remember from your pre-calc days. It's just another way to say inverse sine. So arc sine and inverse sine, same thing. So y equals the inverse or arc sine of x squared. Now, I'll give you a second to think about it, and if you want to pause the video and see if you can take the derivative, okay? And if you can do it from memory, even better, but if you need to go back and look what it is, that's okay. See if you can find the derivative of this. And you can pause the video and then hit play when you're ready to see what it is. Okay, so hopefully the first thing you saw here was that it's no longer the derivative of the inverse of x, it's the derivative of inverse of x squared. So I have a function on the inside of this inverse trig function, which means hopefully you recognize it's the chain rule, okay? So we're going to take the derivative of the inverse sine function, leaving the inside the same. So it's going to be dy over dx equaling 1 over square root of 1 minus, now normally it would just be x, okay, but notice here my inside function is x squared. So what I need to put where my x normally goes is the function x squared. And remember that that inside function, which is normally x, but in this case is x squared, needs to be squared. So it's dy over dx equals 1 over the square root of 1 minus x squared squared times the derivative of the inside, the derivative of x squared being 2x. Okay, and if you want to combine this into 2x over the square root of 1 minus x to the fourth, that's fine, but we're not going to do that. Okay, we don't need to simplify derivatives unless you're asked to. All right, so really the only tricky thing you need to be worried about with these is the chain rule. Look for any functions on the inside that you might want to watch out for. Let's do one more together. Let's try number 3. Now, if you didn't pause the first one and you watched me do this one, why don't you pause here, taking the derivative of inverse secant, you might need to go back and look at what that is. Take the derivative of inverse secant, then hit play when you're ready and see if our answers match. Okay, so hopefully you did the inverse derivative, and let's take a look at what that would be. So let's first identify the inside function, which is x squared minus x. So we're going to take the derivative of inverse secant, leaving the inside the same. So if you remember, derivative of inverse secant is going to be 1 over, okay, x, but in this case it's the inside function's not x, it's x squared minus x. So it's going to be x squared minus x times, okay, the square root normally would be x squared minus 1, but I don't have x in there right now. I have x squared minus x. So it's going to be, why did that turn gray? I don't know. I don't really care. So we need parentheses, x squared minus x, close the parentheses. Okay, so it's x squared minus x squared minus 1. This is all under the radical. Okay, so again, normal inverse secant would be 1 over x times the square root of x squared minus 1. But in this case, since it's the chain rule, I have to put that entire x squared minus x on the inside. And then we have to multiply it by the derivative of the inside, multiplied by the derivative of x squared minus x. I'm going to make a mistake here and see if you catch it. So it would be times 2x minus 1. Catch the mistake? Order of operations would say you would multiply the 2x times that whole fraction first and then subtract 1. But we need to multiply it by the derivative of the inside, which is 2x minus 1. That needs to be in parentheses. So if you didn't have that in parentheses, that would be minus half a point or minus a point there, okay? So watch out for things like that. Okay, that is derivatives of inverse trig functions. Really the only thing you need to be careful about, right, is the chain rule happening and watching out for the derivatives of the inside. Other than that, there's really not a whole lot to it. It's really just memorizing those 6 trig functions and then going from there.